Chemistry paper 2, theory 2021 GCE paper. Allow me to go through this section A of this paper, then we'll do section B later on. So we go to question 1. The diagram below shows an experiment in which ammonia is reacted with hydrogen chloride. Study it and answer the questions that follow. We've got that tube there, mark X. This is HCl, ammonia side. What was observed at point X after a few minutes? A white precipitate, a white cloud if you like. Okay, by what process did the particles move from the ends to point X? Diffusion. Okay, diffusion. I don't know if this is the spelling for diffusion, but that's the answer. Define the term you have given in B above. Movement of particles from a region of their high concentration to a region of their lower concentration. What causes the process in B to stop? When equilibrium is reached. When equilibrium is reached, diffusion stops. E, by drawing, show how the particles are arranged in the compound formed at point X. Okay, the fact that this compound is precipitated, it's a solid, it may appear like a cloud, but eventually it becomes hard, like it's a salt. Okay, which is ammonium chloride. Okay, it becomes hard. It's a salt which is crystalline in nature. At first I didn't really understand. I was almost starting to draw something else, but I had to draw something like this. It's a solid, it's a crystalline solid. Therefore, my smaller particles here are ammonium particles, and then the bigger ones are chloride particles. Because chlorine is heavier, ammonium is lighter. So I had to draw something like this, some kind of a regular arrangement of particles, because I know it's going to be a crystalline solid. Question 2. The arrangement below is used to separate a mixture of two liquids. Okay, therefore that's our arrangement. This is fraction distillation, fractionating column, the beads, Liebig condenser. Look at the water movement, distillate. What do we call liquids that are separated by these methods? They are referred to as miscible. They are miscible liquids, therefore they mix completely to form a solution. Name apparatus Z and give its function. This is our Z. Liebig condenser, okay, and then its function is to condense vapor to liquid. So question C, what would be wrong in interchanging the inlet and outlet of water for apparatus Z? Look at the inlet here and the outlet. Remember, water has to flow opposite to the vapor to maximize the cooling effect. So if you interchange this, you allow the exit to be here and the entrance to be there, the cooling effect to be reduced. Therefore, the cooling effect would reduce. That would be the effect. D, what general term is liquid B called and what makes it possible to be separated from its mixture with A? That is our liquid B, our distillate. The answer is distillate. It's lower boiling point than liquid A. Therefore, if you have liquid B before liquid A comes out, it means it had a lower boiling point. It's distinct boiling point from liquid A. Question 3. The following diagrams show the electron arrangement in shells of 4 elements X, Y, and Z. Which of these elements represents nonmetals? You have to look at the elements with more than 3 electrons in the outermost shell. If the electrons are 3 or less, then it's a metal. So W and Y are nonmetals. Which 2 elements will form a compound with a formula of the type A2B? A2B. My answer was Z and Y. Okay, Z would be the A and then the Y would be the B. Okay, C, X can react with Y to form an ionic compound. Define ionic compound. Okay, ionic bond, ionic bond. Link between ion and cation. Okay, link between an anion, link between an anion and cation. That's an ionic bond. Or if you like, a force of attraction between an anion and the cation. Number 2, write the formula for compound formed. Compound formed by who? By X and Y. My answer was X2, Y3. You have to look at the valencies. Okay, X, where's X? The valency for X is 3. This is a metal. It loses 3 electrons. The valency for Y is 1, 2, 3, 4, 5, 6. This is more like oxygen, okay, and this is more like aluminium. Okay, so if you have to have a compound of oxygen and aluminium, it will have this. It's like aluminium oxide. X2, Y3 will be the ratios. Number 3, draw the structure of this compound. Use outer shells only. Okay, so this will be the basic appearance of the two. This will be your Y, and that will be your Z. I don't know if they did want me to write boxes or they wanted me to write electron diagrams, but they've said draw the structure of this compound. Use outer shells, meaning they just want these shells. So, or maybe I should have written, okay, I think this would have sufficed, because writing multiple oxygen and aluminium ion, like surrounding oxygen, surrounding aluminium, would have been cumbersome. But these would be the appearance of the basic particles in terms of their electron shells, outer shells, and their charges. Question 4. Silver chloride is an insoluble salt that is prepared by precipitation. Name one of the reactants that can be used to prepare this salt. Ammonium chloride would be a reactant in this reaction. Write an ionic equation that with state symbols for the reaction of the named reactant in A with any other reactant. Write an ionic equation. Okay, not just an equation, but ionic equation. So ionic equation is this one. I don't know if they wanted a net ionic equation or just an ionic equation, but this is a net ionic equation, and this would be the case here. Aqueous silver reacting with aqueous chloride to give us solid silver chloride. How did I arrive on that one? I had to imagine that ammonium chloride is reacting with silver nitrate, a soluble salt reacting to give us an insoluble salt and a soluble salt, ammonium nitrate. So I just cancelled off. I ionized everything that was in aqueous. Then my final equation remained with this equation here. Then I plugged it there. See, some stages in the process of preparing a salt are filtration and washing the salt with distilled water. Give the importance of the stages in separation of the salt. Filtration separates the silver chloride from the salt in solution, therefore the aqueous one. Washing removes the remains of the soluble salt. Okay, that's just that. The silver chloride is a normal salt. What is the difference between a normal salt and an acidic salt? Give an example of an acidic salt. Normal salts have no basic or acidic properties, while an acidic salt yields protons when dissolved in water, of course, e.g. sodium hydrogen carbonate. When this is dissolved, there will be this proton aspect that will be floating around the solution in which the salt has dissolved. Question 5. 6.8 grams of magnesium reacted with 0.5 molar hydrochloric acid of volume 1 decimeter. Write decimeter cubic. Write a balance equation with state symbols for the reaction. Magnesium reacts with hydrochloric acid to give us magnesium chloride and hydrogen gas. Show by calculation which of the reactants was in excess and by how much. To find the mole ratios, therefore to find the mass of acid in this concentration and this volume, then I already have this mass here, or in other words, I have to find the moles of acid. So moles of magnesium are these, moles of acid in the 1 decimeter is this. Then I compare these moles, the moles in the equation here, they're supposed to be 1 to 1. 2 moles reacts with 2 moles to give us 2 moles and 1 mole of this. But this is way too little. Okay, this is way too little, so it becomes our limiting reagent, and this one becomes our excess reagent. Therefore, magnesium is in excess. In excess by how much? Therefore, it's supposed to be 1 to 1. So this amount of these moles of acid reacted with equimoles of magnesium. Therefore, this reacted with 0.014 moles of magnesium. Therefore, only this much magnesium managed to react. Therefore, the excess was by 0.269 grams. Therefore, its excess is 0.269 grams. Question C. Calculate the volume of hydrogen gas produced at room temperature and pressure. Okay, so since you have the limiting reagent, which is your HCl, and you know to say the mole ratio here is 2 moles of HCl produces 1 mole of acid. Therefore, you use this mole ratio to simply guide you in the amount of moles of acid that would have been produced when 0.014 moles of acid reacted. Therefore, this will be the moles of gas, not acid, gas produced. Therefore, convert these moles to volume, it gives you 0.1698 decimeter cubic. Question 6. Iron 3 oxide is reduced by carbon monoxide during the extraction of iron. Construct a chemical equation for this reaction. Therefore, that's our equation. Always remember to attach chemical status symbols, okay, physical status symbols. B. Justify why the reaction is a redox reaction. Carbon monoxide gains oxygen and iron 3 oxide loses. Therefore, it's a redox reaction. Write the reduction half reaction. Therefore, iron is 3 plus here, and then this charge is reduced to 0. Here it has no charge, so it has reduced from 3 to 0, and this means that this is our reduction equation. That's our reduction equation in this reaction. For us to obtain this is what happened. That's why this is iron, two iron atoms, or 2 moles of iron, so I simply draw this. Which substance is the oxidizing agent, and explain your answer. Iron 3 oxide is the oxidizing agent because it gets reduced. Okay, as simple as that. Number 7, the elements bromine, fluorine, iodine, and chlorine are all found in group 7 of the periodic table. This topic comes from the periodic table. Arrange the given elements in descending order of reactivity. Fluorine is the most reactive, bromine is number least in this one. Number 2, where are these elements placed in the periodic table? Why are these elements placed in this group of the periodic table? Because they have 1 electron in their outermost shell. Here I was thinking of valency, so I ended up valence is 1 because they have 7. Okay, they are in group 7 because they all have 7 electrons in the outermost shell. What is the name given to group 7 elements? They are called halogens, which means salt formers. They all react with metals to give you salts. Number B, sodium can react with chlorine to form sodium chloride salt, according to the equation below. What difference would be there if sodium reacted with bromine? Explain your answer. Okay, the salt formed would be more dense. Okay, they haven't specified whether the difference would be, you should align yourself to the chemical difference or physical difference. So here I went to the physical side. Bromine is heavier than chlorine, so the salt formed would be more dense because bromine has a higher mass. What would happen if lithium was placed in sodium chloride solution? Explain your answer. Nothing would happen because lithium is less reactive than sodium. Therefore, lithium will not be able to displace sodium from its compound. I think we have scored 7 marks there, people. Zinc is extracted from zinc sulfide. The ore is heated strongly in air to give zinc oxide and a gas. Name the gas produced from this reaction, sulfur dioxide. You don't write the symbol, you name it. B, give 2 disadvantages of releasing this gas in air. Okay, by the way, this is our last question in section A. We'll have to do section B another time. Can cause acid rain. When it dissolves in water droplets in the clouds, it can actually cause acid rain. As the water drops, it will absorb this gas. Irritates lungs if breathed in. Okay, it has got this irritating effect once you breathe it in. Therefore, it forms fumes or dilute acid solutions in our lungs and even in our eyes if it's too much. Number C, zinc is used to galvanize iron sheets. Why are iron sheets galvanized by zinc? My answer starts from somewhere. Okay, but you can still answer direct to the question so that you don't waste this space. Because despite, oh my gosh, look at what I wrote. Despite it being more reactive, I was almost starting with the answer direct, so let me just remove this. So let me just go to, despite it being more reactive than iron, it forms an insoluble coating of zinc oxide. Okay, so iron is galvanized or coated with zinc because zinc forms an insoluble. This is a key word here. Insoluble coat of zinc oxide, meaning that once zinc oxide is formed on the iron sheets, corrosion will not progress because the layer which is formed on top is insoluble. So despite it being more reactive, it forms a coat. Okay, because someone might get confused, say it's more reactive, but again it is somehow in some way sacrificed. It's not sacrificed, it's actually forms this coating here. So the last question there is, give one other industrial use of zinc in making of batteries. Okay, this marks the end of our section A for this paper, which is 5070 paper 2 2021 chemistry. I'll see you in the next video or in the video for section B. Remember to subscribe and leave your comments. Au revoir for now.